Hello! Last time, we made spaghetti. We also learned how to wire a Speeduino standalone ECU. If you haven't seen that video, go watch it. It is indeed riveting. In any case, now that we have completed engine wiring, we have unlocked the ability to, well, we can't run our engine yet, and we can't really tune our engine yet, but we have unlocked the ability to become a cool engine tuning nerd. Because who needs friends in their passenger seat when you have a laptop with Tuner Studio? In this video, we will be taking our freshly wired ECU and turning it into something that will hopefully make spark go zap and fuel go squirt, and engine go. Quick note, I will be covering my journey configuring Tuner Studio, and I'll do my best to explain how different settings may apply to different setups. However, due to this being my first time delving into the world of standalone ECUs, I'm sure this video will be far from comprehensive. So if you are knowledgeable in this area, feel free to share in the comments or correct any egregious errors I have made in this video. The first step in our journey will be installing firmware onto our Speeduino. If your Speeduino is like a stick, then firmware is like the magic pixies that turn the stick into a magic wand. I actually don't know if that's a good analogy, but I do know we need firmware. So make your way over to the Speeduino manual and the install firmware section. Here you will find a bunch of different links to download Speedy Loader for different operating systems. So go ahead and download that and open it up. When you open Speedy Loader, you'll be greeted with all the different versions of the firmware here. You're probably just going to want to select the most recent one. And then, once you have selected the firmware you want to use, click Choose Port. A page will come up with available ports, and there's a few different options here, so we have to choose the correct one for our ECU. One way to do this is, currently my Speeduino is plugged in. I'll unplug it, and COM5 disappears. So plug it back in, and you can see it's pretty clear that COM5 is our Speeduino. At first, when I was trying to figure this out, I was not getting anything popping up. That's because I didn't have the correct driver for my specific Speeduino Ocelot. So I needed to download this driver from the Silicon Labs driver here. So I'll probably leave a link in the description for that. If you are using the Speeduino Ocelot and you're having that same problem as not detecting the port, this might solve your problem. Anyway, back to Speedy Loader. Select the appropriate port, and we're going to go upload. Now, most Speeduinos, you can just click upload, it will upload the firmware. With the Ocelot, after you upload the firmware the first time, so consecutive times, there's a button you have to press to allow the firmware to upload. So I'll go ahead and do that. There's a little bit of a trick with the timing. Basically, you want to press the button, hit upload, and release the button right away. Otherwise, if you don't time it right, it won't upload. So I'll press the button, and then upload release. You'll know it's working because it'll give you a percentage here of the firmware loading to the board. Another thing to take note of here is it'll show you the Tuner Studio definition file, and it'll give you a location in the downloads, and it'll give you the name of the file here. So make note of that file because we're going to need it later when we're setting up our Tuner Studio project. Okay, upload completed successfully. Very good. Now that you have uploaded your firmware, you're probably going to want to get a bass tune. It's generally a good idea to have some kind of bass tune so you're not working with a completely blank project. Basically, this bass tune is like a foundation to work off of. Otherwise, you can end up with some weird values in your tune. So go ahead and click Get Bass Tune, and it'll give you a bunch of options here. If one of these tunes fits the description of your project, then go ahead and get that. Otherwise, just get this Speeduino generic bass tune and go ahead and download tune. It'll come up with this warning that bass tunes are basically, they need changes and they won't work as is. And it also says to make sure to change the board in the tune to the appropriate one you're using. The tune is designed for the 0.4 board, so we're going to need to change that to our Ocelot. We'll go ahead and download that. And actually, well, this is the third time I've downloaded it, so well, I will just click cancel because I already have it downloaded. Anyway, now we have our bass tune. We should be all done with Speedy Loader. Next, we're going to need Tuner Studio. So we're going to make our way to EFI Analytics, and there's a few options here. You can get the free version of Tuner Studio, and that will get you started, but there's going to be some features you don't get, obviously. The main one being the ability for Tuner Studio to tune for you from your oxygen sensor readings. Tuner Studio can tune for you. So if you want that option, you might want to look into the paid versions. If you want to find all their different products, their website is a little janky, but go to products and connectivity. That'll bring you to this page, and you can click software. They have Tuner Studio as well as lots of other different softwares here, dashing softwares and such. And then there's also like upgrades if you are upgrading your software, and combos. If you want to buy a bundle, then this is the place. Anyway, once you have made your decision and downloaded Tuner Studio, we can go ahead and open that up. So we will open up Tuner Studio and go ahead and create new project. So name your project something that makes sense. Now, under this firmware section, this is where that Tuner Studio definition file I mentioned earlier comes into play. You can click detect, and it will most likely detect the firmware off your ECU. However, I have had this also not work, so we'll just go into the other /browse place, locate my downloads, and select the .ini file and open. Now we can go ahead and click next. And here it's just going to ask you some basic questions about configuring your project. So we'll go ahead and change that to Celsius because I'm not a crazy Fahrenheit person. We will stick with PSI and enable hardware test. They leave this disactivated because you can cause damage to engine components, particularly your ignition. So you can leave that deactivated, but you can also just activate it and then not do dumb things. And make sure you have the appropriate Arduino controller. For most cases, that's going to be the Mega 2560, and that should be all we care about here. This stuff can also be changed later on, of course, from your project. Now we need to tell Tuner Studio what port our computer is. So we'll go ahead and go COM5 again because we know that's our port, and the baud rate should be 115200. I don't know what that is, but pretty sure that's what it's supposed to be. But you go ahead and go test port, and hopefully it'll come back successful. Wonderful. Now go ahead and click next. We'll just leave it the default gauges for now and click finish. And here we go. It'll load the project. You probably won't get this low oil pressure warning. That's something that I set up in Tuner Studio. You can ignore that. Now the first thing we're going to want to do is load our base tune. So we'll go File, Load Tune, MSQ, and we'll locate our base tune, which should also be in our downloads. And we'll just, these should be the same, but this one I downloaded more recently. And we'll go ahead and open that. Now we'll ask, would you like to send and burn configuration to controller? We'll go ahead and click yes, and it will say settings change that require power cycle to take effect. You can just unplug your computer for a second, your ECU, and plug it back in, and that should make those take effect. Alright, we have loaded our base tune, and we are ready to transcend to the next level of tuning nerd. This can be a little daunting, to say the least. There are a metric shit ton of settings in Tuner Studio, some of which will probably destroy your engine if you get them wrong, and some of which probably don't apply whatsoever to what you're doing. This also means making an instructional video on how to Tuner Studio is kind of a brain twister, especially for a noob such as myself. I thought long and hard on how to convey Tuner Studio in a somewhat digestible way, and I've settled on a few key points which will hopefully be somewhat universally applicable, and which I myself found less than obvious when learning myself. Right off the bat, we will talk about engine constants. So go to the Settings tab and go to Engine Constants. This window will pop up, and some of this stuff will probably be information you will know about your engine. First off, we will start at the top with required fuel, or required fuel calculator. This basically takes your engine parameters, such as your displacement and your injector flow rate, number of cylinders, also what fuel you're using, and it will calculate the amount of fuel required at 100% volumetric efficiency to run your engine. So basically, you'll put in all your different parameters and you will click OK, and it'll come up with a number here. It'll calculate for you a number. This is in milliseconds, and it is basically the pulse width of the required fuel at 100% volumetric efficiency. Next, we have control algorithm. This is also an important one, depending on your setup. The two main ones are going to be MAP and TPS. So MAP for your manifold absolute pressure sensor and TPS throttle position sensor. This is the sensor that your computer is going to use to calculate how much fuel. Some of this other stuff is obvious, like number of cylinders, number of injectors, injection type, even fire here. Most engines will probably be even fire unless you have something like a non-90 degree V engine or something that your firing events are not going to be in even order. Then you'd have to go odd fire and fill out here the angle of each firing event. Another thing to take note of is the squirts per cycle and the injector staging. It's probably best, depending on your setup, to refer to the Speeduino manual on what to do here. But for my setup, I'm using alternating because I'm using sequential injection, and I'm not the biggest expert here, but for sequential injection with 4 injectors, it recommends 2 squirts per cycle on the Speeduino manual. Something very important here is your board layout. So I've actually already changed this. This generic Speeduino tune has the 0.4 board. If you're using the Ocelot, as I am, there is actually no Ocelot board listed here, but the correct one to select for the Ocelot is the UA4C board. Also, obviously, if you're using the UA4C board, you'd also select that. Next, injector layout is obviously going to depend heavily on your injector layout. You have paired, semi-sequential, and sequential. Again, I would refer to the Speeduino manual for this, depending on your setup. And map sample method will be the last thing I'll go over. This is basically you have instantaneous, cycle average, cycle minimum, and event average. Cycle average is probably the most commonly used. For my setup, I use cycle minimum because I have heard it's recommended for individual throttle bodies. And then you have a switching point based on RPM. It'll use instantaneous, the instantaneous method here, below that certain RPM. And after you make changes on something like this, you are going to want to go ahead and burn those changes to your ECU. So it's good to just make a habit. Every time you change something, just hit the burn and it will update your ECU. Next, we will touch on trigger setup. So that's also in settings and trigger setup. This again is something that will heavily depend on your specific setup. There are a lot of different trigger patterns, and on the Speeduino manual it explains, there's a page that explains essentially what all these different patterns are. I'll quickly explain my setup for demonstration purposes. I'm using a dual wheel setup, which means I have one crankshaft wheel and a camshaft wheel with a single pulse. So that'll either be a single tooth on a wheel, or in my case, on my R1 engine, it is actually a notch in the wheel. So the primary base teeth, that will be the wheel on my crankshaft. And you can see I have the primary trigger speed set to crank speed because the wheel's on my crankshaft. And the number of teeth is 8 for me. Next, we have the trigger angle in degrees. So to see what that angle actually is, what it's looking for, if you click the question mark here, it'll give you a little blurb of what it is. This is actually quite useful, by the way. Anytime you're looking at settings and you're not totally sure about what it is, often you can click the question mark and your question will be very conveniently answered. But you can see the angle after top dead center when tooth number 1 on the primary wheel passes the primary sensor. So that's great, but we have an even number of teeth on our 8-tooth wheel. So where is tooth number 1? Well, tooth number 1 is defined as the first tooth to pass your primary wheel sensor, so the camshaft position, or sorry, it's the first tooth to pass the crankshaft position sensor after the camshaft position sensor is triggered. So you have a single pulse on per revolution of your camshaft. So after that triggers your camshaft position sensor, then the first tooth to pass your crankshaft position sensor is your number one tooth. So what I did, I printed out a piece of paper with a degree wheel and I put it on my crankshaft and measured that angle physically. You're going to want to get this angle as close as you can before ever running your engine, but once you actually start up your engine, you are going to want to confirm your ignition timing with a timing light, and if your ignition is off based on where you set it, this is actually what you'll want to adjust rather than your actual ignition timing. You'll see we have some more stuff down here. It says trigger edge and secondary trigger edge. So will be the trigger edge, obviously the primary trigger edge. This will be either rising or falling. This will depend a bit on whether you're using a VR sensor or a Hall effect sensor for that given sensor, and it also will depend on which VR conditioner you're using. If you're using a VR conditioner, it'll likely actually say when you purchase the VR conditioner what it needs. So in my case, it is falling. I have also heard that in certain cases, the wires on a VR sensor may need to be swapped in order to make the falling edge the clean edge. So that is something to keep in mind. If your VR sensor is not reading properly, you can try switching the wires, and that may potentially solve the problem. I will very briefly mention injector characteristics. This is again settings, injector characteristics. This, I'm probably going to make a video all on its own on how to calculate both your injector flow rate and your injector dead time, or what they call here injector open time, also known as injector latency. This is a little bit too much to dive into in this video, but I will most likely make a video on this particular topic. If you do have your ECU plugged into your engine and sensors and everything while you're doing this, you will probably notice that none of your values for things like throttle position, map, and temperature sensors make any sense. So we're going to have to calibrate the sensors. So to do this, go to the Tools tab here, and you're going to see various options: calibrate throttle position sensor, calibrate pressure sensors, calibrate temperature sensors, calibrate AFR sensor. We'll start with the throttle position sensor, as this is probably the easiest. I don't have my computer plugged into my engine at the moment, but basically what you're going to want to do is have your throttle closed, and then where it says closed throttle, you're going to click get current with your throttle closed, and it will then know that that reading for your throttle position sensor is for 0% throttle, and then you're going to open your throttle up all the way, obviously without the engine running, and then click get current with the throttle all the way open, and that will calibrate your throttle position sensor. That's literally it. Next, we'll take a look at pressure sensors. Now, calibrating your pressure sensors is very easy if you are using the built-in map sensor and barometric pressure sensor on your Speeduino ECU. So there's basically just a list of different sensors here. So all you have to do is select the given sensor for your ECU, and then it should be calibrated appropriately. If you are using a different sensor, which is not on this list here, then you can actually use a pressure gauge and a vacuum pump and figure out the actual voltage that your sensor puts out at a given pressure. As you can see here, you can enter in numbers for the kilopascals or whatever units you're using for pressure at 0 volts and 5 volts. So if you were to calibrate your sensor, what you would do is plot on a graph 2 or ideally even more points, and then draw a line through that graph, and then you should be able to plot those points at 0 volts and 5 volts on your graph and calibrate your sensor that way. But definitely a lot easier just to select a sensor from a drop-down list. All right, temperature sensors. So with temperature sensors, again, there is a list of common sensors. So if your sensor is listed here, then that is fantastic. If not, you can do a similar thing as with the pressure sensors, but this time it is resistance rather than voltage, and it needs 3 points because it is actually a curve rather than just 2 points like the pressure sensors. So it is a matter of using a thermometer and some water. So for example, how you do this is you would get some water, get it, boiling with a thermometer in it, hopefully an accurate thermometer. Read the temperature on the thermometer, and with a voltmeter, read the resistance of your temperature sensor, and then you'd put your temperature here and your resistance in ohms here. And then you choose another point, probably somewhere around 50 degrees Celsius or something, and again you'd put your temperature there and resistance here, and then you'd repeat the process somewhere close to freezing probably, and put your temperature reading here and your resistance there. And lastly, we will talk about the AFR sensors, or your O2 sensor. So here again, it is possible to put custom values for your sensor, but it's a little trickier to test this, and you'd probably have to research the custom values for your particular oxygen controller. But in most cases, your controller will probably be in this drop-down list, as most of the common ones used are here. In my case, I am using a 14.7 wideband controller, so that's what I'll select, and it's as easy as that. Oxygen sensor calibrated. If you start clicking through the different tabs in Tuner Studio and seeing all the different things that it has to offer, you'll soon realize that I have very barely scratched the surface with all the different settings. As I mentioned before, a shit ton of settings are in Tuner Studio. And in case it isn't obvious, a standalone ECU gives you so much control over an engine, which is why it's so great, but it also gives you total control to screw things up. So basically, before you actually start your engine and start tuning your engine, what I would recommend, and it may seem a bit tedious at first, is just start clicking on stuff. You might be surprised what you can learn just in Tuner Studio itself. Like I was mentioning before with things like the question marks, all these question marks have a brief description of what the setting does. So just by going through settings, filling in what you do understand, and where you don't understand, hit the question mark, and maybe you will understand it. Otherwise, obviously, you have to research it. And obviously, good places to research. The Speeduino manual is the first place I would look. But also, I haven't mentioned this yet, but there is the Speeduino forum, which has some incredibly helpful people on it. So if you can't find your answer in the manual, I would highly recommend the Speeduino forum. If there isn't already a thread answering your question, there are some incredible people there that will help you out. There are a few topics I would like to make more in-depth specific videos about, like I mentioned about testing the injectors. So let me know if there is interest for that, and I will likely do that. Anyway, let's just finally get to why you all came here. Will my engine start, or will it blow up, make a massive fireball, and burn down my shop? Place your bets in the comments. Ow, my ears. As you can probably tell, it was running pretty terribly in that clip. This actually turned out to be just fouled spark plugs. Who would have known that when your air-fuel ratios are all gobbledygook, your spark plugs can foul really quickly? Throughout the process of getting a rough tune on this engine, this is probably like the 15th time I had to clean the spark plugs. Alright, run better now. But here's a clip after cleaning. It's a lot better, but still definitely needs work.